Section 8.4, Adding, Subtracting, and Multiplying Radical Expressions. Well, as you can see, when we were multiplying, we just had to have the same index. But when we add or subtract, you have to have like radicals. Like radicals are radicals that have the same index and the same radicand. That wasn't true for multiplying or dividing. We just had to have the same index. But to add or subtract, we have to have like radicals. It's kind of like if you tried to add x plus x. You could do so because they're like terms. But if I had x squared plus x, those are not like terms. So if I had the square root of x plus the square root of x, we can put those together. But if I had, say, the cubed root of x plus the square root of x, I cannot do it. So make sure you understand what it means to be like radicals. So how do we add or subtract? Well, we're going to simplify all the radicals because a lot of times they're not going to be the same at first. And then to combine any like radicals, make sure you just add or subtract the numbers in front. You don't do anything to the radical. Just like if I wanted to add x plus x without that square, x plus x, you would get 2x. But you can't do anything with x squared plus x. So like radicals, keep that in mind. So add or subtract, assuming that the variables represent non-negative values. Again, we don't want to worry about negatives under the radicals. So first things first, to add or subtract, we have to have the same radical, and we do. So what do we do if we have the same radical? All we have to do is add or subtract the numbers in front. So 6 minus 5 is 1, leaving the radical unchanged. We don't need the 1 because it's understood to be there. So my answer is the square root of 3. Now looking at number 2, we need to make sure we have like radicals, and we have the square root of 6 all the way across. So now we can go ahead and start subtracting or adding depending. So we're going to have 5x minus 3x, which is 2x square root of 6 minus 2x square root of 6. Well, 2x square root of 6 minus 2x square root of 6 is 0 square root of 6, which is just 0. So you don't have to show all those steps, but I do want to show you how we get to that final answer. So on number 3, do we have the same radical? Yep, so we can add or subtract the numbers in front. There's a 1 in front of this radical, so 1 plus 9 is 10, and leave the radical unchanged, so we get 10 cubed root of 2. So those are already pretty straightforward because we already had the same radical. But now look at number 4. We have the square root of 48 minus 3 times the square root of 27. As you can see, we do have the same index, and that's good, but we cannot add or subtract unless we have like radicals, which means same index and same radicand. So what do we need to do? Well, what do the directions say? Simplify all radicals. So what can we take out of the 48? Starting with the factor tree, that could be 4 times 12. 4 is 2 times 2, and those are prime. 12 is 2 times 6, 2 is prime. 6 is 2 times 3, and we finally get to the prime factorization of 48. We want to be circling pairs. We have a pair of 2's, and we have another pair of 2's. So a 2 comes out, a 2 comes out, and a 3 is left underneath. So far we have a 2 coming out, a 2 coming out, and the square root of 3 is left underneath. Now let's do the same thing with the 27. 27 is 3 times 9, 3 is prime. 9 is 3 times 3, so now we have a prime factorization of 3 times 3 times 3. So 3 comes out, but what's already out there is a 3. So 3 comes out, a 3 is already out there, and a 3 is left underneath. 3 is all over the place. So now we can see we have 4 square root of 3 minus 9 square root of 3. So we end up with 4 square root of 3 minus 9 square root of 3. Now that we have the same radical, we can subtract 4 minus 9, so we get negative 5 square root of 3. Alright, so looking at number 5, none of the radicals are the same, but we do have the right index, so that's good. So I'm going to go ahead and jump to what should come out. Make sure you understand what comes out and what's left underneath. So we're going to have a 2 already out there, a 5 comes out, an x comes out, and a 2 should have been left underneath. Minus, we have the 8 and the x already out there, a 3 should have come out, and a 2 should have been left underneath. Minus, we have a 3 on the outside, a 6 should have come out, and the x's should come out, and we're left with a 2 underneath. Now why is the x out? Again, because power divided by index. Same thing on the first term, power divided by index. So we end up with 10x 24x square root of 2 minus 18x square root of 2. Now that we have like radicals, we can go from left to right. 10x minus 24x is a negative 12x, and a negative 12 and a negative 18. I'm sorry, no, it would be 10x minus 24x is a negative 14x, and a negative 14x and a negative 18x gives me a negative 32x square root of 2. Alright, so on number 6, we look to make sure we have the right index, and we do have the same index, but we don't have the same radical yet. So let's go ahead and do the factor tree on the 81. Or you can look what my math lab does. It says find the perfect or the nice cube. But 81 is 9 times 9, 9 is 3 times 3, and 9 is 3 times 3. So we're going to circle triplets because again our index is a 3. So a 3 comes out because that's really 27, and the cubed root of 27 is 3. And we're left with the cubed root of 3. Plus, the 24 would be 3 times 8. 8 is 2 times 4, and 4 is 2 times 2 2's. But what's already out there is a 3. So we have a 3 on the outside, a 2 comes out, and a 3 is left underneath. So we end up with cubed root of 3. And so that just ends up being 9 cubed root of 3. Don't forget your index, right? So we end up with 9 cubed root of 3. So on number 7, I'm going to let you try number 7. Again, all you're going to be doing is power divided by index, having some variables come out. Your final answer should be AB cubed root of AC squared. So just try your power divided by your index and get some things to come out. Alright, so now we have 48x cubed plus 12x cubed. Again, we have the same index, but we don't have like radicals yet. 48 would be like 4 times 12, and 4 is 2 times 2. 12 is 2 times 6, and 6 is 2 times 3. Again, the more you know your multiplication well, the better these problems are going to go. So we're going to have a pair of 2's, and we're going to have another pair of 2's with the 3 left underneath, and we still have to take power divided by index. So if 4 comes out with our power divided by index, that means it goes one time with the remainder of 1. So one of the x's comes out, the 3 is left underneath, and 1 x is left underneath. On the 12, we have 2 times 6, and 6 is 2 times 3. So again, we have a pair of 2's, and a 3 is going to be left underneath. Power divided by index does the same thing. So 2 comes out, and x comes out, and what's left underneath is the 3x. Those are like radicals, so now we can take the 4x plus the 2x, and we get 6x square root of 3x. So remember, when you're adding or subtracting, your radicals do not change. What's underneath stays the same. Outside, you add or subtract. Alright, so looking at number 9, we have a 135. When you see a 5 at the end or a 0 at the end, you know it's going to be divisible by 5. So take your calculator and just do 135 divided by 5. And you're going to see it's 5 and 27. So this is going to be 5 and 27, 5 is prime. 27 is 3 times 9, and 3 is 3 times 3. Look at what your index is. Your index is a cubed root of pairs. So we have a triplet of 3's. So 3 comes out, but what's already out there is a 4. So 4 is out there, a 3 comes out, leave a little bit of space for the variable, and a 5 stays underneath. We have a power of 5, so 5 divided by 2 can go twice with the remainder of 1. So that means c to the second comes out, and c to the first is left underneath. So now we'll do the same thing on the next one. We have a 320, so we know it's divisible by 10. So we have 10 and 32. 10 is 5 and 2. 32, well, there's different ways. I'll say 4 times 8. 4 is 2 times 2. 8 is 2 times 4. And 4 is 2 times 2. So we got lots of pairs, or triplets. We have a triplet of 2's there, and we have another triplet of 2's there. So that means a 2 comes out, a 2 comes out, and a 5 is going to be left underneath. So what's already out there is a 6C. Oh, sorry, that should be a minus sign. 6C. 2 comes out, another 2 comes out. Don't forget your index. And we have the cubed root of, we have C to the second underneath. I'm sorry, I should have been dividing by 3. That's my bad. We have the, again, forgetting the index. 3 can go into 5 one time with a remainder of 2. So C to the first came out, C squared's left. And on this one, what stays underneath is the 5, and a C squared is left underneath. So this is a messy problem. I apologize. 4 times 3 is 12, so we have 12C cubed root of 5C squared minus 6C times 4 would be 24C. Again, cubed root of 5C squared. So now, because we have the same radical, we can do 12C minus 24C. And 12C minus 24C is a negative 12C cubed root of 5C squared. So again, making sure you have your index all the way down and don't forget it like I was. So now we want to be able to find the product and simplify if possible. This is going to be putting together the two sections. How do we multiply? And then how can we add or subtract? So be very careful with this section. Again, we're going to assume that the variables represent non-negative values. Well, when we multiply the numbers are outside the radical, and we multiply numbers underneath the radical. But you never multiply a number outside underneath. So be careful, don't ever take the 4 times the 5. Now what are you going to take the 4 times? What's the number in front of the radical, which is a 1. So 1 square root of 5 times 4 is 4 square root of 5. Minus 1 square root of 5 times the square root of 5. That's when you multiply 5 times 5 and you get 25. So numbers outside get multiplied, numbers underneath get multiplied. But never take a number outside underneath. So we end up with 4 square root of 5 minus the square root of 25 is 5. Now a lot of students want to try and combine these, but what did we just learn? To add or subtract, we have to have like radicals, and we don't. This would be like trying to combine 4x minus 5. You can't combine 4x minus 5, so don't combine 4 square root of 5 minus 5. You can't do it. You have to have like radicals. So on number 2, we look to multiply, and again we have to have the same index when we're multiplying, and we do. So the square root of 7 times the square root of 5 is the square root of 35 minus the 3 is going to be on the outside times the 1, which is just a 3, and then we're going to have to multiply 7 times 14, and 7 times 14 is 98, so we get the square root of 98. Then we try our factor tree. Well, 35 is 5 times 7. Well, those are prime and there's no pairs, so nothing comes out. 98 was 7 times 14, and 14 is 7 times 2. So we do see that a pair of 7s is going to come out, and we also have a 3 there. So we get the square root of 35 still, minus the 3 is already outside, so 7 comes out, and what doesn't come out was that 2. So we end up with the square root of 35 minus 21 square root of 2. These are not like radicals, so you can't do anything more, so you're done at that point. So be careful. You can multiply radicals as long as the index is the same. But if you want to add or subtract, you have to have like radicals. So I'm going to let you do number 3, but I'll give you the answer. The answer would be 10 plus 3 square root of a minus a. So make sure you can get to that answer by just multiplying the 5 times the 2, 5 times the square root of a, and the inner as well. So let's do number 4 together. We have the square root of 5 times the square root of 2, which is going to be the square root of 10, because we're allowed to multiply the 5 and the 2. On the outside, we get the square root of 5 times 7, which is 35. On the inside, we get the square root of 2 times 2, which is 4. And at the last, we get the square root of 2 times 7, which is 14. 10 is 2 times 5, there will be no pairs. 35 is 5 times 7, no pairs. Square root of 4 is 2, and 14 is 2 times 7, no pairs. So really the only thing we can do with this problem is take the square root of 4, which is 2. There are no like radicals, so we cannot combine anything else. So again, I'm just trying to make sure you realize you have to have like radicals to be able to add or subtract. So looking at number 8, we'll multiply numbers outside times numbers outside and numbers underneath times numbers underneath. So 8 times 2 is 16, square root of 2 times 5, which is 10. Then 8 times 3 is 24, square root of 2 times 10, which is 20. 2 square root of 3 times 2 square root of 5 with that negative is minus 4, square root of 15. And negative 2 times 3 is negative 6, and 3 times 10 is 30. So then you look to see if you have anything that can come out of it. Now 20 is 4 times 5, and 4 is 2 times 2. So you do have a pair of 2's. Nothing can come out of 15 because it's just 3 and 5. Nothing can come out of the 30 because it's 3 times 2 times 5. So no pairs. So our final answer is going to be 16 square root of 10 plus, we already had 24 on the outside, times the 2, which is 48 square root of 5, minus 4 square root of 15, minus 6 square root of 30. No like radicals, so I'm done at that point. So on number 6, we have the cubed root of 9 times the cubed root of 9, which is the cubed root of 81. We have the cubed root of 9 times negative 2, so negative 2 cubed root of 9. 5 times the cubed root of 9, so 5 cubed root of 9. And 5 times negative 2 is negative 10. So 81 is 9 times 9, and 9 is 3 times 3, and 9 is 3 times 3. We need to circle triplets because our index is a 3. So 3 comes out, and the cubed root of 3 is left underneath. Don't forget your index. Now these are considered like radicals, cubed root of 9 and cubed root of 9. So negative 2 plus 5 is 3, keeping the radical unchanged, cubed root of 9. And then we still have minus 10. No other like radicals. This is a cubed root of 3, this is a cubed root of 9. They're not like radicals, so we cannot combine them. So how do we do the square root of 5 minus 3 quantity squared? Well, to be able to do that, you make sure you write it twice and FOIL it out. Don't change any signs. When you square something, you multiply it times itself. So when you do so, the square root of 5 times the square root of 5 is the square root of 25. Outer gives you minus 3 square root of 5. Inner gives you minus 3 square root of 5. And the last gives you a plus 9. The mistake students make is they like to square pieces, and you can't do that with the minus sign. Write it twice and FOIL it out. So the square root of 25 we know is 5. These two are like radicals, so we'll put those together. Minus 3 and a minus 3 give me a negative 6 square root of 5, and we still have plus 9. Don't stop. You still have like terms with the 5 and the 9. So 5 plus 9 is 14 minus 6 square root of 5. Alright, so on number 8, let's go ahead and do the distributing. We have 4 times 4, which is 16. Outer is going to give me negative 8 square root of 3, because 4 times negative 2 is negative 8. Inner gives me a positive 8 square root of 3. Now what does the last give me? Well, 2 times negative 2 is negative 4, and 3 times 3 is 9. So this is negative 8 square root of 3, this is positive 8 square root of 3, those cancel out. So I get 16 minus 4, and the square root of 9 is 3, so 3 comes out. We get 16 minus 12, and 16 minus 12 is 4. So lastly, number 9, we have the square root of 3 times the square root of 15, plus the square root of 8 times the square root of 10. So multiplying those, we get square root of 45 plus the square root of 8 times 10, which is 80. So 45 is 5 times 9, and 9 is 3 times 3. So we see that we have a pair of 3's. So a 3 is going to come out, and a 5 is going to be left underneath. 80 is 8 times 10. 8 is 4 times 2, and 4 is 2 times 2, and 10 is 2 times 5. So we have a pair of 2's and another pair of 2's. So a 2 comes out, another 2 comes out, and the 5 is left under the radical. So we get 3 square root of 5 plus 4 square root of 5, which ends up being 7 square root of 5. Because remember, when we add or subtract with radicals, we leave the radical unchanged.